Okay, so my plan of attack today is just to sort of run you through a fairly condensed version of our Chemical Card Plus course, which is our version of the chemical accreditation program, which is the 2 units which are nationally required as part of your chemical accreditation. Some states, I think Victoria and Queensland, add on an extra unit in some circumstances. So these are the two units that cover chemical handling, application, transport, storage, those general parts. So it's a bit of a condensed version, but if anyone does need to update their chemical accreditation, you'll be well on your way to doing that after having done this. And I've got details about our chemical courses at the end. Okay, so we've got everyone from a bit of a mixed sort of background. And I'll use the chat box a bit during it. I like a bit of interaction. It's a bit lonely here otherwise, talking to myself. So sort of as a starting point for, hopefully this is going to change. Why is my screen not changing? There. As a sort of starting point when we start looking about chemicals and using pesticides, we need to make some decisions about our pesticides. So should I use a pesticide, and which pesticide will I use are our starting points. So we've got a paddock here that's been overrun with a weed, and we're thinking about cleaning it up. It's probably a little hard to see, but we've definitely got lots of green in the paddock, and there looks to be a fence line up the back. What sort of pops to mind if you were looking at this paddock and you wanted to use it for something and it was not this purpose of growing a weed? What might be some of the things you might think about before you just launch in with anything? Okay, so burn off, spray, then graze. Might there be some questions you might need to ask yourselves? Excellent. What's the paddock going to be used for? So that is a good starting point. Has anyone got the critical one that we might need to know? That's a good one. What's close by? What else is in there? Ooh, now I've got my thing running. What's the weed? Yeah. So we need to know what we are dealing with, what we've got. So before reaching for the drum, some things to consider. And now you've got a close-up of that weed. Probably most of you would have this growing in your areas. Is anyone familiar with what that weed is? So this weed is fleabane, so spread around most of the country these days. So some things we need to consider. Firstly, we need to identify what the weed is, or if it was a livestock issue, what the pest is, what we're actually dealing with. We need to find out about it. So the likelihood it will be a problem, the life cycle, recognising different stages of that life cycle, and our different options for control. So not necessarily just chemicals. We've got a whole variety of other options that might be worth considering using. So learning about what we're dealing with, our flaxleaf fleabane, it's distributed right across the country. I think these days West Australia's got a lot more, and yes, it is in Tasmania as well. We need to know about the life cycle. So typically fleabane has an autumn germination. It grows during winter and spring and mature by the time we get round to summer. It's a very adaptive weed, and these days it will germinate whenever there's a shower of rain. It's also a bit of a problem because each plant can produce about 120,000 seeds, so it spreads rapidly. So if we were to start to look at putting together a plan to control fleabane, some things we need to consider. Good farm hygiene. So it pops up all around sheds and fence lines and edges of roads, wherever there's no competition, it grows. Our crop and pasture competition is really important as a method to combat it. Grazing can be useful. Sheep in particular are pretty good. Cultivation is excellent. If we can bury the seed, it won't germinate. Fleabane actually needs sunlight on the seed to make it germinate. So it really needs to be lying on the surface. So as soon as we bury it, it's no longer able to germinate. And finally there, we can use chemicals strategically. So using alternate modes of action, which is our double knock approach, has proven to be very successful. And if we consider all of these different options, we're looking at parts of integrated pest management, which I'm sure you guys are all very familiar with. But I guess my way of describing IPM is it's a bit like a toolbox. And if we think about, a ute, a toolbox on a ute, we don't just have one set of tools in that toolbox. We've got a whole collection of different drawers, and those drawers are filled with different items. So in terms of agriculture and our IPM, we've got our biological control methods, we've got chemicals, which obviously includes herbicides, fungicides and insecticides. We've got our cultural methods, which are our management decisions, and also our sort of more physical options that we can use. And part of why we need to consider IPM is resistance. So it doesn't matter whether we're looking at weeds or insects, resistance is an issue. And in every group of pests, there'll be a couple that are just naturally resistant to your chemical. So if our red plants here are our resistant plants and we spray with a chemical, we're obviously going to take out all of our green ones and be left with those red plants. What will happen to those red plants? What will they do? If anyone wants to type. Yeah, they're going to reproduce and fill that paddock. And then we end up with this. So if we go back in again and spray with that same chemical, and I guess Roundup, glyphosate is a really good example of this happening, we're going to have absolutely no effect. And Roundup is one of our most useful herbicides, but unfortunately we have had an over-reliance on it and we keep going back and back with it, and we are selecting these populations. So we really need to start considering different options, and it might be an IPM approach, it might still involve chemical, but it's got to involve a different mode of action. So a pesticide kills a pest by interfering in processes in that pest. And this is the mode of action. The mode of action tells us how a pesticide kills that pest. Pests that survive the chemical process, I'm covering my slides here with things. Pests that survive the chemical have processes that are not affected by the chemical. And they will survive any other chemical that has the same mode of action. So mode of action, something on this that is changing at the moment, you may be aware of it. In our herbicides, we've always had letters. By 2024, we will only see numbers. And one of those files that Anna shared with you is from CropLife Australia, CropLife. It's a little hard to read, but if you go to their website, they've got a whole collection of resources there explaining the new mode of action tables. And some of them are set up really well that they give you the new number and what that correlates to with the old letter. Because I think every farmer in Australia is very used to seeing letters. It's going to take a little while to get our heads around that our Group A's that we use in crop are no longer Group A's, they're Group 1s. So we find this mode of action information on the front of our label, front of our chemical drum, not just herbicides. This will be the same for insecticides, our animal health products. We'll see that mode of action on the drum of drench. It's sitting right there. So critical piece of information. I'll just go back to that. I guess we'll go into looking at chemical labels, but what are the other key pieces of information? And I guess thinking about doing this course today, I now sort of, not only do I do training work, but I'm also the mother of a nearly 13-year-old boy who's about to come home from boarding school in a couple of weeks, and he's busting to be able to drive the spray rig. We're not quite there yet, but there's plenty of 15 and 16-year-olds in our area that are spraying. So all of a sudden you sort of do really think we've got to start our serious education process here at home. But what are some other key pieces of information we can see on that label? And I guess there's one thing there that I hope and I guess when I go into schools, what I want everyone to be able to recognise instantly when they see a drum of chemical. Yeah, the caution label. So we'll talk more about this, but knowing that caution that we can see there, if we read that first word, that's going to give us a very good understanding of what sort of content is in that drum, particularly when we see dangerous poison there. If it's a dangerous poison, we know that the content in that drum has the potential to kill us. So we'll go on, yes, active ingredient and PPE requirements. We'll find them deeper down. We see the active ingredient there on the front of that drum, and we'll find the PPE requirements on the label. But the signal heading is absolutely crucial. The other thing when we're thinking about chemical storage that jumps out to us on chemical drums are diamonds. What sort of diamond might we want to make sure that we're aware of what's going on with our products? So our dangerous goods diamonds are another critical indicator of seeing what's there. Yep. So whether it's flammable, again, if we've got a drum that's flammable, it's a very quick indicator that we need to consider what we're doing with it. So signal heading and dangerous goods symbols are really, if we can pick those up instantly, that tells us a lot. Now, I also got Anna to send you a copy of a booklet from the APVMA, and it uses this Joe Bloggs label. It's sort of pulled out apart for you in sections, but basically every label is laid out in the same fashion. And if we can get a handle on how to read these, it's then transferable between products. So this is a lovely one-page example. Typically, you're going to find 10, 20 pages in a chemical label. But if we can learn where everything's placed, we can then find that information really easily. So that first thing we see, I guess, well, first of all, it's broken up into 5 sections. Our first section there, section A, is our warnings and product description. And the first thing we see is our signal heading. So our signal headings, we have most dangerous, which is dangerous poison, caution, and then what's called no signal heading. It'll basically just say read the safety directions, are the least hazardous products. Our product name, our type of chemical is number 3, our active constituent, which is effectively the ingredient in the drum, but always important to consider the formulation, the grams per litre or grams per kilogram, because these days, there's a lot of different products that have multiple formulations. So we need to know which one we're dealing with. Our resistance group, our mode of action group. So this one here is a group I, but as I said before, expect to see numbers there shortly. Number 6 tells us a brief description of what the chemical does, and number 7 is the contact details for the manufacturer. Section B, and this is probably the section that we when we're using a product that we generally go straight to, working out what to use, what we're trying to kill, and how much of the product we need. So the directions for use section covers restraints, so where you must not use the product, and it will include any spray drift restraints, including mandatory no spray zones. Then we have our actual directions for use table. So we'll find information on different crops or situations, pests that are killed, states that it's registered in, application rates, withholding periods, and any critical comments. And I guess when we're talking about this chemical label, really important to remember that it is a legal document. So by using the product, we're saying that we're going to use it legally. And I guess something that often comes up, you know, we see there we're going to kill, say, aphids in barley. I'm in New South Wales. It's not registered in New South Wales, but it's registered in Queensland. I'm only 90 k's from the Queensland border. Can I use it or not? It's registered in New South Wales on oats and wheat. Can I use it on my barley? No. How could I use it? If that was the only product left in Australia, how could I go about using it? Yes, get an off-label permit from the APVMA. So there are plenty of products that there are off-label permits for, and quite often it's because the company hasn't done the research to get it on the label, but legally we need to get that off-label permit to be able to use it. So below that, so that table quite often on a chemical label will go for multiple pages. Below that we'll see any not to be used for any purpose statement, and withholding periods. So withholding periods relating to harvest, grazing, or cutting for stock feed, which are also really critical to abide by those. Section C includes our general instructions, so resistance warnings, compatibility, can we mix that product with other products? Mixing instructions, is there a particular order that this product needs to go in? APVMA compliance instructions for droplet size, so this is particularly important with any of the phenoxy herbicides. And then section D, we run into our precautions. So in section D, we'll find re-entry periods, plant back periods, protection of crops, natives and other non-target plants, protection of livestock, protection of wildlife, fish, crustaceans in the environment. The final section on our label, which really should be read in conjunction with the safety data sheet, is the first aid, storage, disposal and dangerous goods. So we'll find information here on storage and disposal safety directions. So what PPE should we be wearing? Do we need particular PPE for preparing the spray, and then do we need to add extra PPE when we're actually applying it? We'll find some first aid instructions there, but this is in this section you definitely want to be referring to your safety data sheet as well. We'll find an APVMA approval number, batch numbers, dates, manufacturer and expiry dates, and the final thing you'll see is dangerous goods diamonds. The other thing we aren't seeing now, which we will have later, is GHS pictograms. So we'll talk about them a bit later. So the safety data sheet, it's that other document that needs to be read in conjunction with your label. It gives more detailed information about the chemicals, ingredients, health hazards, safe handling and storage, emergency procedures, environmental effects and safe disposal. In my chemical courses, you know, these days there's a lot of people using paraquat, which is a dangerous poison. There's quite often incidents commercially, and it's one of those products that if you're going to be using that, you need to have read that document and know what to do, because I'd hate to be in a situation where you had someone with chemical on them and you're fumbling around trying to read it for the first time. So you've definitely got to have them, but to actually know what to do, I think is really important. So you must have, legally, you must have a safety data sheet available for every chemical being used on your farm. Use the information on the label and the safety data sheet when assessing risks. So we quite often get asked, you know, can I just have my phone and I can get it up on my phone? One of our trainers is a fresh care auditor, and in his mind, having access on your phone does not work unless you've actually got it downloaded as a file that you can access offline. So otherwise, if you go back to the old, you know, buy a ream of paper and print your safety data sheets and put them in a folder so that you've got access to them. But I imagine in schools, you are all over your safety data sheets. So some other things we need to consider when choosing which pesticide to use. Is it legal to use? How toxic is it? Is it a dangerous good? How likely is it to drift? Residues and withholding periods, and other things like cost, compatibility, and equipment. So is it legal to use? Legally, you can only use pesticides that are registered by the APVMA for particular use and situation. Refer to the directions for use on the label, or you have an off-label permit from the APVMA, as we discussed previously, or a vet has prescribed an animal product for you to use. Generally, to apply any chemical legally, you must read, understand, sorry, I should say general rule. To apply any chemical legally, you must read, understand, and follow all the directions on the label. So as we talked before, how toxic is it? The signal heading tells us this, and this example here, it's a caution as well. So in increasing toxicity, we have our no signal heading, which is an S4, caution, S5, poison, S6, dangerous poisons are our S7s. So our dangerous poisons, they really, anything with a dangerous poison, we have to have absolute serious respect with what's in that drum. Obviously, all chemicals we should, but those dangerous poisons are the ones that will kill us. Considering whether it's a dangerous good, so my little way for remembering our diamonds, girls like diamonds, coloured diamonds in this case are our dangerous goods diamonds. And these products will have an immediate effect on people, property, or the environment. I'm sure everyone's pulled up next to a fuel truck or an explosives vehicle and seen some diamonds there. These days, we're finding a lot of products have this miscellaneous dangerous goods 9 diamond, and I don't think we've got it here. There's an environmental one too. So I was just having a little look in our chemical shed this morning, and yeah, there's a lot of products that you wouldn't actually consider normally to be a dangerous goods, but they are. They do have dangerous goods diamonds on them. And our GHS pictograms. So we can pick these as being different from the dangerous goods diamonds, that they've all got a red border around them. And these are an indication of hazardous chemicals. So you will find these pretty well on every chemical label, or sorry, they're on the safety data sheets, but you'll find these everywhere. And there is a little bit of, I find in chemical courses, there is a little bit of confusion with students as to, is it a dangerous good diamond or is it a GHS pictogram? We also need to consider when we're using agricultural sprays, how likely is it to drift? So some chemicals are more volatile, for example, 2,4-D and MCPA. These are members of the phenoxy family. They're more likely to drift away off target, and there's a risk if you will damage your own or someone else's crops or pastures. So we need to try and choose less volatile chemicals to reduce this risk. We'd always suspected that it was probably the cotton industry that was putting pressure on the way this course, like the chemical accreditation course, has been structured, because there's a bigger focus on spray drift these days. But apparently it's actually been the grape industry, because they're affected by 2,4-D just as much as the cotton industry. I'm not sure if anyone has, sorry, I've just got a child that's come through the room. Not sure if any of you are involved, have grapes or cotton nearby. Probably no cotton, but there might be some grapes not too far away. Yeah, so the grapes. So of course we need to consider our residues and withholding periods. So we need to be very aware of traces of chemical in your product. So product being wool, meat, grain, fruit and vegetable. Terms that we need to be familiar with: MRL, maximum residue limit, WP or WHP, withholding period, and our ESIs, export slaughter interval. And these are legally enforceable. So when we're talking about legally enforceable, our chemical label is one legal document. We then treat our crop or our animals, and then we sell our product. And we are signing, these days, you sign a vendor declaration or a commodity declaration for everything you sell, which is another legal document. And you get picked up, you've got some pretty big legal issues there, because multiple legal documents that have been read or signed. Some other things we need to consider: cost. So I guess we're not all farmers in this room, but usually in a course, farmers, we don't like spending money. We do things the cheap way, but unfortunately the cheap way is not always going to be the best way. We need to consider, compatibility with other products. Can we actually mix two products, or do we have to apply them in two different passes? And the equipment we've got available, is ours suitable, or do we need to consider getting a contractor? So everything we've discussed so far, we can sort of put together in a bit of a checklist. Do we have the correct name for the pest? Will this chemical fit into our IPM plan? Is it registered for this use? How toxic is it? Will its mode of action help slow resistance? Is there a withholding period or ESI? Is it likely to drift? Is it compatible with any other chemicals we use? And is our equipment suitable? And if we sort of run through that checklist and refer to the information on the label, we've got the information to select our right chemical. Okay, keeping within the law, so some legal issues and risk management to consider. So we have three sources of law: common law, Commonwealth law, and state law. Our common law, we have a duty of care, responsibility to everyone in the workplace. If you cause harm or injury to people, property, or the environment, this can be deemed as negligence and make you legally liable. If I spray my paddock and it ends up on yours, you're not going to be happy and you're going to no doubt sue me. We also have that responsibility to people around us and making sure that we're looking after them. Our state law, and I'm not even going to admit to having any idea what the state law is in Victoria and Tasmania, or South Australia, sorry. But we look at, state law looks after our WHS, environmental law, our training for users of pesticides, transport of dangerous goods, and our food safety law. So on the WHS, as an employer, it's the employer's responsibility to provide PPE, and the employee it's their responsibility to wear that PPE. We will talk more about PPE later. Our Commonwealth law is administered by the APVMA. They register chemicals, approve labels, approve formulations and containers. They're the issuers of the off-label permits, and they will find that APVMA number on every label of registered products. Now, PPE. Why do we need to consider PPE? This is a really great little picture of how susceptible different parts of our body is to absorption of pesticides. So as a guess, well, I shouldn't say guess, but I'll put it out there. What are the first pieces of PPE everyone grabs? And if you want to talk to me in the chat box. Goggles, you're good. Gloves, yep. Gloves and glasses. And I guess because you're teachers, you're much better than the old farmer. But from this slide, we can see, I would say for most people, it's gloves. Gloves are the first thing they grab. But different parts susceptibility, if we use our forearm as a base level of 1, scalp 3.7, forehead 4.2, eyes are really susceptible 12, palms of our hands 1.3, abdomen 2.1, 11.8 for the genital area, and the ball of the foot 1.6. So while we all grab gloves first, generally, that eye protection is absolutely crucial as well. Our disposable overalls, a hat, and rubber boots. I guess, boots, one thing that, we all wear leather boots. Leather boots, if you get lovely and wet, if we know we're going to be wet, we need to have rubber boots on. So I just keep moving my chat boxes around here. Symptoms of pesticide poisoning. Common symptoms are sweating, headache, chest pains, giddiness, pinpoint pupils, blurred vision, nausea, stomach cramps and diarrhea, and drooling. When in the chemical course, most people are aware of times when they have had these symptoms that they haven't covered up well enough. A lot of people are very conscious when they're spraying insecticides. There's the synthetic pyrethroids, that they get headaches and sore eyes after using it. In a commercial sort of sense, it's probably a fairly good indicator that they need to change their filters on their tractor cabs, because we really do have good PPE if you cover up when you're preparing, and that if your application method is through a tractor these days, enclosed tractor, you're well protected. When we're looking at applying off motorbikes or by hand, we really need to make sure we've got respirators. But again, follow the label and follow those instructions that it tells us. With our PPE, we obviously need to make sure it's in good condition. Make sure that after we've used it, that we're cleaning it, throwing away anything that is damaged or worn, and replacing it. So if we look at managing risk in WHS, you're probably all familiar with the SAFER acronym: spot the hazard, assess the risk, fix the problem, evaluate your fix, and record what you've done. A risk control hierarchy for minimising our risks. If we look at elimination, stop using the chemical machine process. Substitution, can we choose a less hazardous substance? Engineering, can we modify machinery to make it safer? Administrative, work practices, training and supervision, and then PPE is that final line of defence. Obviously, when we're using pesticides, we need to include PPE at the top because we have to wear it legally as part of our label instructions. When we get round to actually using our pesticide, a little bit of planning for how we're going to apply it. So critical to read the label. Are the chemicals registered for this purpose? Do I need to use any adjuvants, so wetters? What application equipment can be used? What are the restraints and environmental protections? What are the recommended application rate? And what are the mixing instructions? What PPE do I need to use? Water quality is something really important to consider too. For a lot of parts of Australia, we're using bore water or dam water for our putting in spray rigs, and poor water quality can adversely affect many products. So rule of thumb, use clean water, check the pH, hardness, bicarbonate levels and total dissolved salts, and you can get test strips to test your pH and hardness, which you guys no doubt have access to through school, but I gather you can buy them through chemists as well. So if you do have poor water quality, look at using additives to adjust it. Our mixing order is really important. If anyone's ever ended up with a blocked filter like in this picture, you will never not follow mixing order again. So we've got our general rule of thumb there for mixing of 2/3 fill the tank with clean water, agitate it, and then our order for adding water conditioners, wettable powders or dry flowable products, water dispersible granules, then flowable liquids or suspension concentrates, emulsifiable concentrates, and then aqueous concentrate or soluble liquids. And then the final thing is the adjuvant, because that's going to make it bubble up if we add it any earlier. So that's our final bit. Fill the tank and with water and use within 24 hours or as label statement. When we look at spray applications, we need to consider the risk of accidental exposure of the operator or others to chemical and spray drift. So spray drift, looking at a planning checklist. Communication, we are meant to be communicating with our neighbours. Looking at our chemical selection, our equipment setup, weather conditions, spray buffer zones, training and record keeping. So spray drift, if we look at our chemical selection, choosing a less volatile product. So rather than using 2,4-D ester, which is our most volatile product, looking at using something that's less volatile. So it might be using amine or MCPA. So these days, like obviously I'm a lot further north than all of you, but 2,4-D ester is banned over the summer months. I'm not sure about in the southern parts where, well, it would be in southern New South Wales too. I'm not sure how that works down south around grape areas. It's probably banned in those areas at particular times of the year. Does anyone know? Is it our grape growers? Yeah. So yeah, using that less volatile product and using products that are less toxic to non-target sensitive areas. Our sprayer setup is also really important. So keeping our nozzle height as low as possible, keeping our travel speed below sort of 16 to 18 kilometres an hour, and using nozzles to give larger droplets. So our labels have specific requirements on many of them for what droplets size we can use. So once again, our label is a legal document. We need to follow those instructions. So for our 2,4-D products, it will say, you know, you must use ultra coarse or extra coarse nozzles. So legally, we need to do that. If this picture just gives a really nice visual of the difference between our different nozzles of what it actually looks like in terms of coverage. So ultra coarse, lovely big droplets, but limited coverage. Very fine, they are going to drift everywhere, but give fantastic coverage. So I guess that the thing to remember is you're not going to just be able to get away with having one set of nozzles. You are going to need 2 to 3 sets really, and these days spray rigs in agricultural areas are getting very, very big and nozzles are not cheap, and this is usually where a farmer, you can see his face screw up a little bit in my courses, but yeah, if we our nozzles on the left here, the ultra coarse, that's going to be great for us in summer, spraying 2,4-D. But come winter, when I'm growing a wheat crop and I need to put fungicide on it, that's certainly not going to cut it. I'm going to need to move back over to a medium or a fine. And part of our issue with drift is inversions. So avoid spraying during a temperature inversion. Do not spray in air movement under 3 kilometres per hour, it's probably, you can even nearly say sort of under 5, and they say nearly under 10 at night time. So I guess it's one of those old sort of things that people, oh, you don't want to spray because there's too much wind. You need wind to spray. You should never, ever be spraying if it's still. Need to recognise temperature inversion indicators, so dust, smoke and ground mist, and avoid spraying at dusk, night or dawn. So a really good indicator of when a temperature inversion is when you're driving down a dirt road and you've got that dust just hanging behind you. You haven't got that air movement, and you've got an inversion there. There's a couple of really good videos through the GRDC website, through their spray drift section, that give it really good visual of what's happening during an inversion and when there isn't an inversion. So I probably should have actually sent them to Anna beforehand.
If you like, Angela, we can put it on at the end.
Yeah.
Yeah.
I can try and find, yeah, actually I could get them. Yeah, I'll find a way of doing something there. Okay, so the other thing to remember is calibration. So our aim is to get the right amount of chemical into mixture to kill the target pest. So questions we need to consider: is my equipment set up correctly for this job, and how much does my equipment deliver? How much chemical do I need to put in the tank? What's my next slide? So we won't go into calibration in great detail today, but in our courses, we do a practical calibration exercise for spraying, but also calibration is equally as important for drench guns and vaccinators. I've had people say that those new, that brand new disposable vaccinators you buy are never accurate. So yeah, calibrating all equipment that we use. Because potentially, if our calibration's out of whack, we're going to be treating things with the wrong amount, which can then affect our residue in our produce. I think it's time for a drink. Okay, so these pictures, spill kits. I'm pretty sure you guys will be all over spill kits, but basic pieces of equipment that we can have in a spill kit are obviously the drum is particularly handy to store everything in. Some PPE gear, our overalls, our gloves. We've got some chemical booms here to slow the spread. We've got some chemical pads there at the back and a plastic bag there to store, to bag up contaminated material in. And of course we can use our drum to fill with contaminated things too. Kitty litter is amazing stuff. Where I used to work, the storeman put a forklift through a shuttle of Roundup, and one bag of kitty litter didn't quite cut it, but it did an amazing job. Also a broom is going to be helpful. The other thing that I think we should have in our spill kits is a shovel, because we're going to need that to clean up the mess at the end. So our spill kit needs to be in our chemical store where we've got quick access to, quick access to it if required. Sorry, I'm not very technologically advanced. Okay, cleaning up spills. What do we need to do? Basic rule of thumb is cover up, put on our PPE, gloves, eye protection, gumboots, control the spill, pick up the drum, replace the cap. Can we do something simple to stop it continuing to spill? Contain the spill using sand, soil or a spill pad. Clean up the spill, remove the spill waste and wash down. And contact. Do we need to notify family members, workers, neighbours, fire brigade, or is it particularly nasty and we need to get the EPA involved? Safe transport. So this is, we use these pictures in our chemical course, and we get students to do ratings and work out what's good, what's wrong. Which of those pictures do you like the look of the most? I guess I need to get my chat box back. Our key sort of parts of looking at safe transport, stacking light things on top of heavy things, making sure our load's secure. Ute it, don't boot it. Don't pack insecticides, herbicides, or fertilizers together. And if we're carrying dangerous goods, there's a bit of a typo there. If we're carrying dangerous goods, do we need to use placards? Now, top left, the truck. Yep, the truck looks pretty good. I just see a comment there from Tanya. Was that a bit before? Why is this? Was that to do with the not spraying? Sorry, I've missed that. Oh, spraying and no wind. Okay, so when we have no wind, it's basically a sign that it's an inversion. And so what happens is that the product gets stuck in the air, and we need wind to actually sort of cause turbulence and to move it downwards. So if we don't have wind, it just is there in the air. Later on, the wind gets moving and it moves that product elsewhere. So typically, what it moves to a lower point, tip down a valley is the typical sort of thing. Yeah, so lingers for longer and can drift more. It's that inversion, that it's lingering there in the air, and then when the air does get moving, it moves elsewhere, off target. So okay, that's good if that makes sense. But the videos, I'll share, get a link for you for those. Okay, so safe storage, safe transport, we've got that covered. And that truck, the one thing we could do on that truck to make that better would be there's a tarp there at the top, so we could pull that over. The ute, it's actually pretty good too. If we assumed he'd finished loading and he put his side up and he was going to tie them down, that non-slip mat in the back is excellent too. And the truck down the bottom, he's got some improvements to make. Oops, I just missed some there. Okay, so safe storage. Some key things that we need to consider for safe storage: is it lockable, ventilated, does it have bunding? All containers must have intact labels. Keep PPE outside the store. So our PPE, while we need it close by, it shouldn't be actually in the storage area. Ideally, it might be a box outside on the shed. Have a safety data sheet for every chemical stored nearby and relevant signage. So these pictures often generate some interesting comments when we're doing our assessments on them. Unfortunately, the picture on the top left there is probably what most family farms chemical storage sheds resemble. They might be a bit better, but family farmers have a lot of improvements that they can make. The best chemical sheds I've seen are the corporate farmers. Because of the WHS issues, and they've got work cover sort of following them, their chemical storages are brilliant. They've also got the budget. But we can, even that really bad one there, we could put a gate across the front, put some mesh and put a gate, big tidy up. There's a lot of things we could do to make that fit the safe storage than where it is now. Enclosed chemical cupboards, they should still have some ventilation on them, to my knowledge. A container has to have ventilation. So I can't see that a closed chemical cupboard is that different. I think some of them might have ventilation on the back of them or the sides, but they should definitely have some form of ventilation. I would imagine chemical storage is in schools. I'm not sure how much chemical you actually have, but they would be pretty schmick. Disposing of our containers and unwanted chemicals. Now there should be an extra little bit there. So anything that's empty, we can clean to drum muster standards, which is triple rinsing, and dispose of through drum muster for recycling. If we happen to have chemical where there is still product in the container, or we're not sure of what the chemical is, the label might have gone, we can get in contact with ChemClear, and they are able to assist us. Although I did have someone locally ring ChemClear recently, and they said they might be able to come and help them in 2 years' time. So that was a bit disappointing. So the next best bet, they were told to contact the council. So there are certainly ways and means of dealing with chemical that's no longer needed. So, oh gosh, am I a bit quick? I might be a bit quick. Maybe we can have a chat. Some general sort of information for us on our chemical courses. Got some prices there. We offer a couple of different modes of delivery. So our face-to-face courses, which are generally only in New South Wales. We offer online self-paced, so basically a Moodle site where you work your way through. We also do classes which is just like this online as a group. We send your materials and then you sit in on a class at a set time. And also you can just do it manually via distance education, the old-fashioned way. At the moment, for anyone in New South Wales, there is excellent funding available. Now, I also just wanted to let you know about some other things we do. So for New South Wales people, students, there's a whole collection of courses that are fully funded if you're under 25. This may be changing, I think, after Christmas. So just for your students, some really good options there. And also, Rural Biz Training offers scholarships. So we have 2 scholarships available every year. And one of these we retain just for a young person, I think. And then one is can be older or younger, depending on who the applicants are. So for rural and regional students. And yeah, please, if you've got anyone interested in maybe doing a Diploma of Ag or a Diploma of Agribusiness Management, please, pass the information on it. There's information links on our website to apply. We would love to have lots of applicants. So I think that's about it from, no, we've got some more. The officers put in a bit more for me. Funding and payment options. So state subsidies, we have subsidies available in Queensland, New South Wales, Tasmania and South Australia. Commonwealth assistance, we're able to offer vet student loans and for approved diploma and advanced diploma courses, and is available in all states. And we're also offer payment plans which can be customised to suit you. And that's our contact details.